Hi, welcome to Always Eclectic Stacy. This is Always Eclectic Chemistry, and you're in our ionic bonding series. Today, you're going to learn how to name ionic compounds, starting with a balanced compound and going to a name. Ready, set, let's balance. And welcome back to Always Eclectic Stacy. We're in our ionic bonding series, and this big question is, how do you correctly name an ionic compound? Well, that depends on two things, so let's look into it. First, you're always going to name the metal cation first, and then you're going to name the non-metal anion. It's going to be your root plus ide. So let's look what that means for just a second. Okay, before we start naming our elements, it's really important to understand that we're always going to name the anion first. The charge and the name for anions are very easy. They don't change, and they're your reference point for when you're going from compound to name for ionic compounds. So N3 minus, you're going to see that as an N, maybe an N with a subscript, is always going to be nitride. Niter, N-I-T-R, is the root, with ide being what you change it into. P3 minus, you can see that with the P in the compound, it's going to be phosphide. AS3 minus is the root arsen, and then you're going to add ide. SB3 minus is antimonide. That antimony root with the IDE, they kind of get switched to antimonyide. O22 minus is oxide. S2 minus is sulfide. Se2 minus is selenide. F1 minus is fluoride. Cl1 minus is chloride. You're going to see all of these without the charges, though, in ionic compounds. So you have to look for the element symbol. Br1 minus is bromide, and I1 minus is iodide. Now remember, you're always going to look at the anion first, so let's do some practice. Okay, let's look at NaCl. We're going to underline the cation is in red and the anion is orange. So we're going to name the anion first, and that's going to be chloride. And then Na is in column 1, so we do know that it's in a transition metal, and you're going to use the whole name to name it. So it's going to be Na. You can look that up on your periodic table. It's going to be sodium. So this is going to become sodium chloride. Let's try another example. Be3 2 minus. I threw this one in here because it looks tricky, but it's similarly as easy. The 3 and the 2 you don't touch. You're only looking at the element. So Be is in column 2, so it is a non-transition metal. So you're just going to use the full name for it. It's beryllium. And N is nitride. So it becomes beryllium nitride. Let's try something a little trickier now. Let's go Cu2O. Now, O, we underline in orange because it's an anion, and we name that as oxide. The trick is with Cu. Cu is a transition metal, so we know that it can have multiple oxidation states. So you do have to use a reverse LCM for this. How that works is you're going to set it up just like an LCM. I'm going to put the copper over here and the oxygen underneath. When I did this originally, this one was blank because we were looking for that, because you fill out the information for O first. You know the charge of O is 2 minus because the charges for anions don't change. And it has 1 as a subscript, so you can do times 1. So 2 times 1 gives me a 2 for the LCM. So you put that up here where the copper is. So you do that 2, then you fill this in. We have a 2 subscript, and then we ask ourselves, what number of charge does the rest make the statement true? So 1 times 2 equals 2. So you know the charge of copper has to be a 1, and that's written in a capital I for a Roman numeral. Let's try one more. Fen. And it's examples like these that I do recommend the reverse LCM for, because there are no subscripts. And we know that iron, Fe, is a transition metal. So we go ahead and we're going to go ahead and set up our reverse LCM, starting with N. N is nitrogen. It has a 3 minus charge. There's no subscript, so there's one of them. So 3 times 1 equals 3. You're going to go ahead and pull the 3 up there, and you're going to do the same. There's no subscript, so it's got one of them. So we have to figure out what charge makes times 1 equal 3 true. That's 3. I'm going to write that iron 3 in Roman numerals with nitride, so it becomes iron 3 nitride, or Fen. Thank you so much for watching. If you like this content, please do not forget to like and subscribe, and I hope to see you again soon. Have a great day.